Cis-Trans isomer for alkanes. Alkanes of the type can exist as Cis and trans isomers. Cis if the two R groups are on the same side of the carbon-to-carbon double bond, and trans if the two R groups are on opposite sides of carbon-to-carbon double bond. Cis-trans isomers are compounds that have different configurations, grouped permanently in different places in space because of the presence of rigid. As a consequence of the double bond, some alkane compounds exhibit a unique type of isomerism. Rotation around the single bond occurs readily, while rotation around a double bond is restricted. The pi bond prevents rotation because of the electron overlap both above and below the plane of the atoms. A single bond is analogous to two boards nailed together with one nail. A double bond is analogous to two boards nailed together with two nails. In the first case, you can twist the boards, while in the second case, you cannot twist them. Geometric isomers are compounds with different spatial arrangement of group attached to the carbons of a double bond. In alkanes, the carbon-carbon double bond is rigidly fixed. Even though the attachment of atom is the same, the geometry, the way the atoms see each other, is different. Geometric isomerism, also known as Cis-Trans isomerism or AG isomerism, is a form of stereoisomerism. Isomers are molecules that have the same molecular formula but have a different arrangement of the atoms in space. That includes any different arrangement, which are simply due to the molecule rotating as a whole or rotating about particular bands, where the atoms making up the various isomers are joined up in a different order. This is known as structural isomerism. Structural isomerism is not a form of stereoisomerism and is dealt with elsewhere. In stereoisomerism, the atoms making up the isomers are joined up in the same order, but still manage to have a different spatial arrangement. Geometric isomerism is one form of stereomerism. These isomers occur when you have restricted rotation somewhere in molecule. At an introductory level in organic chemistry, examples usually just involve the carbon-carbon double bond, and that's what this page will concentrate on. Think about what happens in molecules where there is unrestricted rotation about carbon bonds. In other words, when the carbon-carbon bonds are all single, alkanes like 1-butane and 2-butane exhibit constitutional isomerism, as they differ in the position of the double bond. Further, 2-butane exhibits stereoisomerism and exists as two distinct compounds differing in spatial arrangement. An isomer is called Cis-2-butane when the methyl group are on the same side of the double bond, and the other stereoisomer in which methyl group are on the opposite side of the double bond is called trans-2-butane. The Cis and trans stereoisomerism are not interconvertible at room temperature because of the restricted rotation of the double bond. In nomenclature, Cis is used to distinguish the isomer where two identical groups, the two chlorines in dichloryl-pentane, are pointing in the same direction from the plane of the ring, and the trans to distinguish the isomer where they point in opposite direction. Cis-trans isomer exhibit a type of stereoisomerism where the atoms have a different spatial arrangement in three-dimensional space. Cis-trans isomerism is of practical importance through its influence on the properties of industrial important materials. Identical compounds may appear to have different arrangements as written, but closer examination by rotation or turning will result into molecules being superimposed. If they are superimpossible or if they have identical names, then the two compounds are in fact identical. Isomers of compounds have a different arrangement of the atoms. Isomer compounds will differ from identical compounds by the arrangement of the atoms. Cis-trans isomerism is of practical importance through its influence on the properties of industrial important materials. One of the most important functions of isomers in the human body is that of enzymatic reactions. Alkanes of the type can exist as Cis and trans isomer. Cis of the two are on the same side of the carbon-to-carbon double band, and trans if the R groups are on the opposite side of the carbon-to-carbon double band. Not only alkenes and trialkylanes exhibit Cis and trans isomerism. Transalkenes are thermodynamically more stable than Cis alkenes due to the less steric hindrance only. E and Z nomenclature can be written to alkenes when alkenes contain four different groups. Alkenes are unsaturated hydrocarbons consisting of one or more double-banded carbon atoms. The alkenes can exist two different stereoisomers, which are known as Cis isomer and trans isomer. Trans isomer have the same groups attached to the opposite side of the double band, which will have less steric hindrance compared to Cis isomer. It is important to note that the presence of the double band does not necessarily lead to Cis-trans isomerism. Being able to tell if a double band has a possibility of isomerism is a very important skill. Cis-trans can occur whenever both double band carbons are directly attached to a carbon and a hydrogen. In this case, interchanging the substituent on one of the double band carbons create a different isomer. If one of the double band carbons of an alkane is attached to two identical groups, Cis-trans isomerism is not possible. Her interchanging the substituent on one of the double band carbons form an identical molecule. Alkenes can be stereoisomeric, even though this is slightly different than what we learned about enantiomers and these stereomers containing chirality centers.